Good morning, children. This is Suresh, Maths faculty from DAV High School, SDSTPS, AP Genco, Nailtour. In this video, we are going to learn Introduction of Geometry, Horizon of Geometry, History of Euclid's Geometry, Introduction to Euclid Geometry, Definition of Euclid's Axioms and Postulates. Related to Chapter 3, The Elements of Geometry. Introduction. The word geometry comes from the Greek word geo, meaning earth, and metrion, meaning to measure. Thus, the word geometry means earth measurement. Geometry appears to have originated from the need for measuring land. This branch of mathematics was studied in Egypt, Babylonia, China, India, Greece, and etc. The people of this civilization faced several problems which led to the development of geometry. Horizon of geometry. In Egypt, ancient Egyptians were the first people to study geometry. For example, whenever river Nile overflowed, whipped out the boundaries between the adjoining fields of different landowners. After such flooding, these boundaries had been redrawn. For this purpose, Egyptians developed a number of geometrical techniques and rules for calculating areas of plane figures such as triangle, rectangle, etc. History of Euclid Geometry. The excavations at Harappa and Mohenjo-daro depict the extremely well-planned towns of Indus Valley civilization. The flawless construction of pyramids by the Egyptians is yet another example of extensive use of geometrical techniques used by the people back then. In India, the Sulabha Sutras textbooks on geometry depict that the Indian Vedic period had a tradition of geometry. Euclid was a teacher of mathematics at Alexandria in Egypt, popularly known as father of geometry. The development of geometry was taking place gradually when Euclid, a teacher of mathematics at Alexandria in Egypt, collected most of these evolutions in geometry and compiled it into his famous treatise which he named Elements. Introduction to Euclidean Geometry. Euclidean geometry is the study of geometrical shapes and figures based on different axioms and theorems. It is basically introduced for flat surfaces. It is better explained especially for the shapes of geometrically figures and planes. This part of geometry was employed by Greek mathematician Euclid, who has also described it in his book Elements. Therefore, this geometry is also called Euclid geometry. Euclid collected all the known work in his time and created Elements. He divided the Elements into 13 chapters, each called a book. Euclid defined around 23 items. 7 of them are mentioned below. Definitions of Euclid's. Euclid thought that the geometry is an abstract model of the world which we can see around us, like the notations of line, plane, surface, etc. He had given these notations in the form of definitions. The first one, anything which has no component is called point. Second one, a length without breadth is called line. Third point, the endpoints of any line are called points which make it line segment. Fourth point, if a line lies evenly with the points on itself, then it is called a straight line. Fifth point, any object which has length and breadth only is called surface. Sixth point, the edges of a surface are lines. Seventh point, a plane surface is a surface which lies evenly with the straight lines on itself. Some more definitions in Euclid's Statements. A sentence which is either true or false but not both is called the statement. Theorems. They are statements which are proved using axioms, postulates, definitions, previously proved statement and deductive reasoning. Corollary. A corollary is a theorem that is usually considered an easy consequence of another theorem. What is or is not a corollary is entirely subjective. Next, we are going to discuss important topic in elements of geometry, that is Euclid's axioms and postulates. Euclid assumed some properties which were actually obvious universally truth. He had bifurcated them into two types, axioms and postulates. Definition of axioms. Axioms are statements which are self-evident or assumed to be true within context of a particular mathematical system. That means some common notations which are used in mathematics but not directly related to mathematics are called axioms. For example, when we say the whole is always greater than the part, it is a self-evident fact and does not require any proof. This axiom gives us the definition of greater than. Some of the Euclid's axioms are below. The first one, things which are equal to same things are equal to one another. Example, if x equal z, comma y equal z, then x is equal y. Another one, if an area of triangle equals the area of rectangle and the area of the rectangle equals that of a square, then area of the triangle also equal the area of the square. One more example for axiom 1. Here, if A equal to B and B equal to C, then A equal to C. Second axiom, equals are added to equals, then wholes are equal. Example, x is equal to y. Here, add z on both sides of the equation. That is, x plus z is equal to y plus z. Then result will also be equal. We can use second axiom as below. Example, x minus 10 is equal to 100. Here add 10 on both sides of the equation. That is, x minus 10 plus 10 is equal 100 plus 10, that is equal x is equal 110. Third axiom, if equals are separated from equals, the remainders are equal. This is same as above. If p equal to q and we subtract the same number from both, then the result will be the same. That is, p minus s is equal to q minus s. Fourth axiom, things coincide with one another are equal to one another. Example, if two figures fit into each other completely, then these must be equal to one another. Next axiom, the whole is greater than the part. Observe this picture. The circle divided into 4 equal parts and each part is smaller than the whole circle. This shows that the whole circle will always be greater than any of its parts. Next axiom, things which are double of the same things are equal to one another. This shows that this is the double of the two semicircles. So, the two semicircles are equal to each other. Next axiom, things which are halves of the same things are equal to one another. This is the vice versa of the above axiom. Postulates. The assumptions which are very specific in geometry are called postulates. There are 5 postulates by Euclid. The first postulate, there is a unique line that passes through the given two distinct points. In Euclid's terms, to draw a straight line from any point to any point. As per this postulate, there exists a unique line joining 2 points such as P and Q. A terminated line can be produced indefinitely. A terminated line means line segment. This shows that a line segment which has two endpoints can be extended indefinitely to form a line. Note that we call a line segment nowadays what Euclid call a terminated line. So according to the present day terms, the second postulate says that a line segment can be extended on either side to form a line. Third postulate. A circle can be drawn with any center and any radius. As per this postulate, we can draw circles with any center and any radius. For example, we can draw a circle on line segment with the center at its endpoints and radius as the length of the line segments. Fourth postulate. All right angles are equal to one another. A right angle is angle measuring 90 degree. As per this postulate, all the right angles are equal, and if we place one right angle over top of another right angle, they will coincide. Fifth postulate. If a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the straight lines, if produced indefinitely, meet on that side on which the angles are less than the two right angles. Here, the line PQ in below figure falls on lines AB and CD, such that the sum of the interior angles 1 and 2 is less than 180 degree on the left side of PQ. Therefore, the lines AB and CD will eventually intersect on the left side of PQ. Topic: equivalent versions of Euclid's fifth postulate. Playfair's axiom. This says that if we have a line L and a point P which does not lie on line L, then there could be only one line passing through the point P which will be parallel to line L. No other line could be parallel to line L and passes through point P. This is called Playfair's axiom. Dear children, today home assignment is practice Euclid's axioms and postulates in Homer book. We will discuss examples and exercise 3.1 problems in the next video. Thank you. Stay home, stay safe.